All right, so today we're going to look at our best friend, the sine function. All right, and we're going to look at his nice little pretty graph. And if you recall about our graph with sine, we know that sine is going to be the y values. So that means we're 0, 1, 0, negative 1. So when I graph it, I've got 0, 0, pi over 2, 1, pi 0, 3 pi over 2, and 2. So get this nice little curve. All right. So we know that with every function, we have an inverse function. And the way we test that is if it's a function, it passes the vertical line test. Well, a sine function passes the vertical line test. But to see if the inverse is a function, we actually have to do the... But to see if the inverse is a function, you actually have to do what's called the horizontal line test. And if I do the horizontal line test, then I see that I've got lines that cross through the function twice. So since I have, since we don't pass the horizontal line test, because basically this purple line is going to hit here and it's going to get here, that means that the inverse of sine is not a function. The problem is we need the inverse of sine to be a function. So a great mathematician was bored one day and he came up with what's called ArcSin. And guys, you know what ArcSin is. It's written like this, ArcSin of x. It's also known as sine of negative 1 of x. All right, so the inverse of sine is also known as the ArcSin. So here's going to be some math jargon, and then we'll talk about what it means. So the inverse sine function, basically what happens is, in order to make the inverse of function, we have to restrict the interval. So we're only going to look at a chunk of the graph instead of the whole cycle. Okay, so we have to restrict the interval from negative pi to pi, because what that does is it isolates a part of the curve. So instead of it being the full curve where it goes back down and comes back up, we're only looking at this nice little chunk of it. And that way it passes the vertical test and it will pass the horizontal line test. So therefore it makes the function and the inverse a function, which makes us all happy. So what we have to remember is that for each value v, negative 1 is less than or equal to v, which is less than 1. Inverse of sine is unique number, u on the interval of negative pi halves to pi halves, whose sine is v, that is da 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 da. Okay? So basically what you need to make sure that you know is this part. Okay? That means the domain of g of x equals the inverse of sine x on the interval of negative 1 to 1, and the range is the interval negative pi halves over 2. So what that means is we're going to look at our unit circle, bring that back in, and since we're only looking at a portion of the unit circle, not all values will be valid. So if I'm asking you for, if we're solving an inverse sine function or ArcSin function, that means that we're only going to be looking at a certain portion, which means we're looking on the range of the interval of negative pi to pi and the interval of negative 1 to 1. So that means we're going to be looking at half of the unit circle that's going to produce a valid solution for an inverse sine question or value. So basically what that means on your unit circle, if we're looking at solutions, we're only going to be looking at from pi halves and negative pi halves to pi halves. So we're only looking at from here to here. So any of our solutions will be in the fourth and first quadrant. Anything that's over here in the second and third will not be a solution on a ArcSin value because it's outside of the domain for the function, for the inverse function. So you need to make sure that you know that. So if you get a value and it asks for what is the ArcSin of root 2 over 2, you don't tell me that it's 3 pi over 4, because 3 pi over 4 is going to be right here, and that's outside of the interval for ArcSin. So that is ArcSin. Let's look at an example so you can actually apply your knowledge, maybe see what I'm talking about a little bit better. So if we've got the inverse of sine to the negative, inverse of sine to the 1/2, we're going to grab our handy dandy little unit circle, and what we're going to do is we know that since I'm dealing with ArcSin, that automatically this over here is not allowed. I'm only allowed in the first and fourth quadrant. So where is sine, the value of 1/2? Well, sine is the y value, and we are right here, and that's negative, so that doesn't count. So the inverse of sine at 1/2 is going to be right here, which is pi over 6. Okay, let's go ahead and look at the other one. Again, it's arcsine. It's the inverse of sine. So again, we're looking in quadrants 1 and 4. Anything in 2 and 3 is not allowed or not legal, as I like to say, and y'all laugh at me. So we need what radian measure is negative root 2 over 2. Well, again, we're looking at sine. That's not it. That's a positive. That's not it. 1/2's not it. 0's not it. Negative 1/2. Ooh, there's 1. That's here. And then that doesn't count. So basically at 315 degrees, we've got negative root 2 over 2. And if I'm at that value, then that means I am backwards pi over 2. I'm sorry, pi over 4, which means that I am negative pi over 4. And I want you to notice that when I labeled this value over here, I know that normally this is 7 pi over 4 on your unit circle. But the thing is 7 pi over 4 is not in this interval. Remember, the interval of sine is negative pi halves to pi halves, and 7 pi over 4 doesn't fall in there. But negative pi over 4 does, which is why the answer is negative pi over 4 and not 7 pi over 4. So I hope that clears it up. If you have any questions, come and see me.